Yeah, we were going for internal structure, right? Now, in the internal structure, the first is the physical conditions of the earth interior. They are the source, especially gravity, pressure, temperature, not gravity, density. सही से नहीं सो ना तो दिमाग थोड़ा सा खराब रहता है, तो just take care of that. Density, pressure, temperature. The information about this, the source of information for all the physical condition is fundamentally derived from the study of volcanism. The study of the lava, its temperature, density of the rocks at different places. Variation in these properties and the unexpected changes in different parts of the earth has revealed many characteristics of the earth, especially the upper part. Density variation is roughly increasing uniformly throughout, with the exceptions of the core. The crustal part has 2.75 to 3. Then it goes on increasing in the core 17. This variation is basically continental crust versus oceanic crust. That's what indicates that oceanic crust is denser as compared to the continental crust. Is the density of the crust. The continental crust has a density of 2.75 and the oceanic crust has an average density of 3. The average density of Earth is 5.5, right? General increase in density is attributed to the increasing कोर और कोर में 17 है एवरेज डेंसिटी. It increases to 17. not the entire core. That has not been revealed by the physical conditions. It is basically revealed by seismology, scientific study of the earthquake waves. And the passage we will discuss that later. Like for example, if you have that, how the that's how geologists conclude that the core of the earth must be made up of nickel and iron. Okay, it starts with the pressure density relationship. I hope you guys are clear with fundamentals of this, and how the pressure density relationship will result into increasing density from top to the core, right? And now when exceptional density found in the core of the earth cannot be explained with simple pressure density relationship, right? So the scientists conclude that that exceptionally high density must be associated with the high density mineral itself. That's how they say nickel and iron. It's like basics. We have already discussed earlier in the basics of geography. I'm just repeating it for few who are new here. Like density is what? Mass per unit volume, right? Now let's assume that this pen has mass as well as volume. So if we apply pressure, we can reduce the volume very easily. The moment we have reduced the volume, the density of the same will increase. So that is because of pressure, right? Now with the increasing pressure, the density of this pen can be increased. But after a point of time, that density cannot be increased even if we apply multiplied time of pressure. Is it clear or not? So density increases with pressure, that is true, but after a point of time pressure cannot increase density, and the very high density found in the core of 17 magnitude cannot be associated or related with the pressure, overlying pressure. Hence scientists conclude that the area must be made up of high density minerals itself, may have higher concentration of heavy metallic minerals. Why nickel and iron? There are so many other minerals which are more denser, which are denser than nickel and iron. It's basically because the nickel and iron is the abundant among the minerals which are abundantly found. Other minerals may have higher density, but they may not be concentrated or found in that quantity to form the core. That's why nickel and iron is treated as, that has been further supplemented. The information is further authenticated or supplemented by the study of the meteorites and seismology, or the behavior of rock, behavior of earthquake waves. In the core area. Temperature, again in this case, is directly proportional to pressure when volume is kept constant. Right? So temperature also increases downward till the core with an average value of 1 degree Celsius for every 32 meters of depth. This increase is not uniform. Throughout. The exception is the zone in between 100 to 200 kilometers from the surface. The average temperature of this area is very, very high. Which can't be explained through temperature, pressure relationship. Consequently, the scientists conclude that the area must have its own source of energy. Among the known sources, only thus the temperature or high temperature is explained through radiogenic heat. This causes melting of the rocks and produces molten rock material called magma. Just like I'm coming, let's finish this temperature part, we'll discuss that. Called magma, and becomes the first source of magma and lava from the Earth's surface. Now, here is the explanation is about the temperature increase. Temperature increases with increasing pressure, right? When volume is kept constant, the temperature will keep on increasing with increasing pressure. Like, for example, this is what we are doing. We are reducing the volume. So there is a change in volume. But if you don't change the volume and keep on increasing the pressure, the temperature will increase. PV is equal to nRT. बचपन से पढ़ते आए होंगे आप, right? So whenever we move from the surface towards the interior of the earth, the overlying pressure increases, and consequently the temperature also increases. So scientists have estimated that the average increase of temperature is 1 degree Celsius for every 32 meter of descent. And that's how the average temperature or the core temperature is around 2000 degrees Celsius. Now, there is a one zone very close to the Earth's surface, that is 100 to 200 kilometers. So, we can estimate that what should be the normal or average temperature of that particular zone with the average rate of increase. We can easily estimate that. Right. For example, if we are assuming that 1 degree Celsius is increasing at 1 kilometer. So, at 10 kilometer the temperature should be 10 or 11 at the most. But exceptionally high temperature, sometimes in going beyond 1000 and 1500 degrees Celsius even, in that short layer. So, the scientists conclude that just 100 kilometer thick upper part cannot increase the pressure up to the extent to generate that high temperature. Right. So, you need further explanation. If pressure is not responsible for such a high temperature in that particular layer, means there must be some other reason for such a high temperature. And that's how I write that among the known sources, the only possible source which can generate that high temperature is the presence of radioactive minerals. Is it clear or not? No. No. Radioactive minerals? What is radioactive minerals? Okay, radioactive minerals are like uranium and all, which can disintegrate, break and generate lot of energy, like atomic bomb, atomic energy, the minerals which are used in that. So they go for nuclear fission and break, and in the process of breaking it generates huge amount of energy. So that high amount of temperature can be only attributed to a particular process of energy generation. And that possible energy generation is only have a possibility through the presence of radioactive minerals. So that's how scientists conclude that there must have been heavy concentration of radioactive minerals in that particular layer, which generates huge amount of energy. And wherever it generates, the temperature might go more than 1500 degrees Celsius, leading to the average temperature of that zone very high. And those radioactive minerals may be present in patches, not necessarily the entire layer is made up of radioactive minerals. Is that clear? No?
How is the energy from radioactive minerals generated? So is it from fusion?
Yeah, process is fission always. Look at here, fusion is basically associated with sun when two particles in it. In the case of radioactive minerals, the radiogenic heat is through fission. When one particle and one atom breaks into two and then keeps on, chain reaction is generated.
Then it is controlled
inside the earth. Obviously, it must have been controlled. Earth itself has a mechanism to control, because it cannot spread beyond a certain point, because other minerals are also present. So they'll act as a bad conductor, and they'll not allow it to go for a continuous extent. So that's why where they generate, they can create lava, and then lava creates everything on the surface of the earth, including the development of plates and plate movements and plate tectonics, earthquakes, volcanism. So such a high energy can only produce this magnitude of shifting or movement when we discuss plate tectonics and all.
So apart from radioactivity, can temperature of the earth can be attributed to primordial heat?
No, that's what primordial heat is also associated with something. Primordial heat is also because of the rotation and the movement of particles within the earth at the time of formation of the sphere. right? But that heat has to have some regularity, right? It can't be concentrated in a one particular point. The heat is increasing 1 degree Celsius for 32 meter. It may be attributed to both the way it has originated, the way particle might have moved. If that is the reason, then there should be a continuous increase or decrease, whatever, there should be uniformity in the process. But some exceptional region is found which shows in the middle of itself or very close to the surface itself slightly higher temperature, much higher temperature than normally you expect. So you need a different explanation. And that again is relatively an assumption, more or less proven nowadays, but is an assumption that because we have no physical access there. Forget about personal physical access, we don't have instrumental access as well in that particular layer. So we conclude that the radiogenic heat or the radioactive minerals are the only possible source which can generate that amount of energy.
Does magma has a radioactive nature?
Yes, it all have. All the rock particles do have radioactive minerals in different proportion. Important role in making the concentration. The the high density minerals will not move as fast as the light minerals. Right. So the proportion will keep on changing. That's why we have different types of rocks. From the magmatic chamber till the top, the rock's density keeps on decreasing. When the continental portion we are talking about, the continent is slightly located much higher than the gravity or center of the earth as compared to the oceanic crust. So for the magma to travel and reach here, its density will be lower. That means the proportion of heavy density minerals will be on the lesser side. In the case of oceanic crust, since it is slightly closer, the proportion of the denser minerals will be higher. That's why it is having higher density, it is having lower density. Top of the mountain will have much lower density as compared to the top of the oceans. So with the increasing height, the density of the rocks present in that area will be lower or lesser. Now that's how the physical conditions has revealed, and that's more or less is an assumptions. That's why seismology is the most important source of information about the earth interior. Sorry. Now it is the scientific study of the earthquake waves. Now earthquake waves generated during an earthquake. We'll discuss earthquake later. Now if you look at the properties of earthquake, now here questions can be different. If the question is about discuss the basic properties of the earthquake, you need to write directly the properties. What are the different properties of earthquake which has revealed the earth interior? The answer will be different. How the study of the earthquake has helped revealing the earth interior? The answer will be different. The way discuss the components or the chemical composition of the earth interior as revealed by seismology, the answer will be different. Getting my point? Like properties, simply directly you talk about. Basically we have two sets of waves. One is major wave and another one is minor waves. Among the major waves, three waves are there, P, S and L. The minor waves, PG, SG, P star and S star. relatively discovered recently. Major waves, the waves which are generated and travels roughly in many directions, especially the P and S. Minor waves which are helpful in revealing the minute details of the upper part or the upper crust. P and S are the two waves. These two waves travel in all direction from the focus or hypocenter in the interior. Hence, also called body waves. Since they move in the interior, they are the most important and authentic source of information. L does not travel in the interior and is confined to the surface, hence called surface waves. Not very important from the study point of view. Common properties, if you look at that. Starting with the speed of all the waves is directly proportional passing medium, the medium through which they pass. P has maximum speed among all the waves, hence also called primary wave, and the later P. On the Earth's surface. The first wave to reach and recorded by on the Earth's surface by any seismograph or seismogram. S obviously secondary wave, second to reach, and L has the lowest speed. Of all, it has second highest. S has second highest secondary wave, that's why the later S. For P wave to pass, the medium must offer resistance. Since all the three states of matter, viz, solid, liquid, and gas, have resistance to particles entering into it, P can pass through all the medium. But the speed will vary according to the density of the medium. That is highest solids, lowest gases. S requires rigidity to pass through. Hence, it can pass only through solids. The speed of S will also vary as the solids have differing density. The medium of L is similar to that of P, the requirement. That is, it can pass through all the medium. This is what we are talking about, the speed, right? The speed, this is what is revealed. This is what has been observed and recorded. The different waves will have different speeds. Now, obviously, this is the study of the speed will help you understand the interior of the earth, right? So, varying speed of different waves, especially P and S in the case of interior revealing, has helped scientists conclude about the general characteristics of the earth interior. The speed of these waves and their entry or exit present the top 100 kilometer, 200 kilometer, 2700 kilometer, 5200 kilometer, 60 to 400 kilometer. Generally, if you look at the S wave, P wave. You can take this diagram from Saminder Singh also. Even almost every book writes about this diagram, the varying speed and of the waves, especially P and S wave in the interior of the earth. Now, as we can see from the diagram, the speed increases in the top 100 kilometers. Means the density increases. Very easy conclusion, right?
More slanting means more speed.
Yes, it is increasing speed, depth. The speed of P and S both decreases in the zone of first 100 to 200 kilometers. Right? Now, if you look at the first 200 kilometers, we can have certain conclusion. Increasing speed means increasing density, right? And there is a layer of top 100 kilometers, which is unlike the other older classification of crust, mantle and core. Now there is a different chemical composition which has certain level of homogeneity in the top 100 kilometers. Right? The speed is continuously increasing. This top 100 kilometer is called by scientists or named as lithosphere. Now this zone is characterized by the presence of brittle rocks with increasing density towards increasing density downwards. The upper part of this lithosphere is now the crust of the older classification. Which has varying thickness. The minor waves, that is PG and SG, P star and S star, have helped reveal further information. The higher speed of these waves along the oceanic crust proves the older belief of Suez that the oceanic crust is denser as compared to the continental crust. So this was a scientist, was a geographer basically. Silica and aluminum, silica and magnesium, and the lower speed in the continental crust reveals the dominance of silica and aluminum. It further reveals the minor details of the crustal features. This is the general possible structure of the crust. The thickness varies. The crust has varying thickness, where the continental crust is roughly around 20 to 30 kilometers, the average thickness is. The oceanic crust has 5 to 6 kilometers average thickness. Sometimes it may be as low as 2 kilometers, the thickness. That's what will be useful in isostasy and talking about the Sial and Sima concept of Wegener when we deal with the continental drift theory. Do make this diagram whenever you are explaining the interior of the earth. Right. Now here the chemical composition as revealed is this portion is dominantly, the upper part has a dominance of silica and aluminum, nicknamed as Sial. That is, the rock which contains silica and aluminum is called granite. And here they have dominance of silica and magnesium below this. That's what you call Sima also. So once there is a concept that Sial is floating over Sima. Now this area has, even below the continental crust, this area has dominance of magnesium. Right. Here the magnesium of this oceanic crust is slightly denser as compared to this, and that's why it is also called oceanic thiolites. In geological parlance, the magnesium present in the ocean, which is relatively denser as compared to the continental crust, and is called oceanic thiolites. This is the discontinuity between crust and mantle. And this is what we call Moho discontinuity. This is the upper crust, which is primarily of silica and aluminum, and this portion is called lower crust. That means below this level it is called lower crust, and the discontinuity, this discontinuity is called Conard discontinuity. No, lower crust will be associated with the fact that wherever the magnesium dominate as compared to aluminum, with the density, so that will be found below the continental crust also.
So there is an interface between both of them.
Yes, and there will always be a discontinuity whenever the two zones are there. So separating a zone which will separate them will be a transition zone. Like for example, if I put my hands like this, right? So these are two different entities. So there will be a line. We can easily understand the demarcation line, that this upper part, this lower part. So when we talk about silica and magnesium and silica and aluminum, these two are zones of different chemical compositions. Let's say top is silica and magnesium, aluminum, and then bottom is silica and magnesium. So there won't be a very thin line which will separate it. There will be a transition zone. That's what we call discontinuity. So above that is dominance of silica and aluminum. So mostly the area of the continent which is found above the sea level will be dominantly having granitic rocks, and below that it will be basaltic rocks. Silica and magnesium is wherever the rocks contains more amount of silica and magnesium, there will be basalt.
Basically, they are having both the components of granite, what is it, that aluminum and
Aluminum and
magnesium.
here all the rocks will have different, almost all. There are three types of groups of minerals. Silicate groups dominates. Silicate, carbonate, sulfides, these are group of minerals which are found in the rock, right? Silicate groups dominate. Among the silicate groups there are 7-8 minerals, right? Silica, aluminum, magnesium, iron, then you have olivine, pyroxene. All these are 7 minerals are there among the silicate. Among the groups of rocks, minerals, silicate dominates. Among the silicate groups, 7 minerals dominate. So depending upon the percentage of these minerals, whenever we see that it is dominantly having silica and aluminum, it doesn't mean that it is purely aluminum or purely silica and other minerals are not found, are found in between crust and mantle. That is the lower line. That's what you are talking about right now, the oceanic crust and the continental crust. These minute details are basically revealed by the minor waves, right? The high speed is decreasing, varying. Even the oceanic crust, the speed is different. Continental crust, the speed is different.
Sir, what is the reason for the discontinuity?
Sorry?
What is the reason for discontinuity?
So discontinuity will always be there. Whenever the chemical composition takes place, let's say suppose at a particular height when the magma is rising, so this height, a particular zone will contain dominance of, let's say, silica and magnesium, and now above that it will be silica and aluminum. So it will not be just like a thin line yahan se, just right here silica and magnesium, here silica and aluminum. Rather there will be a zone. In the lower part of this transition zone, there will be dominance of silica and magnesium, yet there will be aluminum. In the upper zone, there will be dominance of silica and aluminum, yet there will be magnesium. So that transition zone will always separate the two zones which has differing chemical composition. It cannot be just cut out by a thin line. So there will always be a zone which will separate purely silica and aluminum and purely silica and magnesium. That zone is called discontinuity. So the continuity is broken by a small thin zone. That will be a zone, not a line, and that zone may contain, may be similar, the upper part of that transition zone will be similar to the upper part, and the lower part will be similar to the lower part. That's why you always have discontinuity, separating a particular, two particular differently homogeneous layer. In the layer in between 100 to 200 kilometers, the speed of both these waves decreases. This proves lesser density rocks present. Right? This proves the presence of lesser density rocks. Since S passes, it can't be in a liquid state. This zone is known as asthenosphere. Astheno means weak. This zone is known as asthenosphere and is believed to be in semi-plastic or semi-liquid state. This is also called low velocity zone, as the speed of the waves is lower here. The semi-plastic state is because of the presence of the molten rock material, that is magma. Produced because of radiogenic heat. in between 200 to 2700 kilometer, waves pass with increasing speed. Proving the fact that the layer has continuously increasing density. Maximum speed of the waves is attained at this zone, nearly at 2700 kilometers. This is called the rocks in this layer is predominantly peridotite with much higher concentration of heavy minerals like iron, pyroxene, olivine, etc. Peridotite is the type of rock. The way we have granite, basalt, rhyolite, gabbro, one is peridotite, which is found in the interior of the earth. The zone of 2700 to 2900 kilometer is considered as the transition zone because the speed of the waves decreases again. This is called Gutenberg discontinuity. Below this, the speed of P waves further decreases and S wave does not pass any further. it proves the presence of, has proved the layer must be in a liquid state. This is the beginning of the barysphere. Or the core as per the older classification. At a depth of around 5200 kilometers, the speed of P wave again increases, proving that the lower portion is in solid state. Lower portion is in solid state. This is the core, which is divided into outer core, that is liquid state, and inner core, that is solid state. The speed has also proven that this speed of P can be in the layer with dominance of nickel and iron. High temperature in the upper or outer core is attributed to its liquid state. Whereas the solid state of the inner core is because of very high pressure.
See, P waves हैं, ये आउटडोर में आती है, तो इनकी स्पीड कितनी रहती है? इस सॉलिड से लिक्विड में गए, डिक्रीज हो रही है सर, लेकिन ये टैप में आती है तो इनकी डिक्रीज क्यों होती है?
Decrease क्यों होती है? So that's why it is proved, na, that outer core of the earth.
It is liquid. So, but doesn't the density also increase as we go deeper to the?
No, that's not. The moment the state of matter changes, then that discontinues. Right, and this decrease, since it has already attained very high speed, so even with the decreasing speed in liquid, that will remain continuously decreasing. the attainment of this area has the maximum speed in the solid. Let's say suppose the maximum speed can be 20 kilometer per second. Let's say suppose in a particular layer, right? And if it is 5 kilometer per second in liquid, the maximum density will provide you this much, and the liquid will provide you 5 kilometer. So the moment it enters with 20 kilometers per second speed. So it has to come back to 5 kilometer because the entire area is liquid, and then there can't be abrupt decrease of speed because it has already, just like for example if you are driving a motorcycle, right, and suddenly you have 100 kilometer per hour, and suddenly you encounter a medium which does not support that speed. So either you skid, fall down, or your gradual speed will be gradually decreasing. In that process you will enter for a good distance in that area. So if you start your bike in that particular medium, you may not be able to cross 40 km per hour. But since you have already attained 100 km speed, the moment you move into that, so for attainment of 40 km you might have crossed that entire area. So since the speed at the bottom of the mesosphere is very high, even with the decreasing speed, may not be able to decrease up to the level what is the normal speed in the liquid layer. So that's why it will continuously decrease here.
So why generalization of waves? Why generalization of waves? Increasing speed increases with the
That's a very generalized aspect.
Why is there disappearing the
It's because S does not pass through liquid state. In the beginning itself we have talked about every wave, or for that matter every characteristics or every entity requires certain medium. For example, we cannot walk on water, right? Basically because our weight requires certain solidity on the surface. We cannot walk on a very smooth surface. So for the humans to move, or for that matter any biotic community to move on the surface of the earth, there must be certain level of friction. There must be certain level of heaviness on the surface, right? That otherwise which can hold our weight. So the requirement for humans to walk is friction and the solidity. The surface must be solid. We cannot walk on gases. At least presently अभी तक तो हम लोग जानते हैं कि we cannot walk on that. Neither on liquid. So similarly, each and every wave requires certain characteristics of the medium through which it can pass. For example, we are able to hear it because air is in between us. So air is behaving or acting as a medium for this. The moment we talk about S wave, S requires rigidity. The medium must be rigid. That's why it is also called shear wave, if you look at that. So because it pushes the particle, and other particle has to cooperate accordingly. So then through this it passes. If the medium is not rigid, S cannot pass. That means S can pass only through solids. That is the characteristics. Why? It's basically because just like that, why can't we walk on the water? So because every wave requires its medium. P can pass through different medium, there will be varying speed. Speed is the most important characteristics as far as the revealing of interior of the earth is concerned.
Sir, are these are present in form of layers or the patches? Like it is molten form. And patches are continuous.
No, that's the continuous. That's the only area which is in the entire layer is in molten form. Had it been patches, then S would have passed through the patches which is in solid state and not through the patches which is in liquid state. But S does not enter into this. And that is why it is in a liquid state. And that's why it is proved, in fact. That's why we assume. Again, it's purely an assumptions based on certain scientific facts without any doubt. The liquid outer core behaves like a dynamo and have heavy concentration of iron. This together with the inner one gives magnetic characteristics or gravity to the earth. Dynamos, the circulation engineer is asking this question to me. What is a dynamo? How does dynamo work? So that the energy is traveling in this direction. So when the liquid core is there, so they keep on moving, floating, circulation, and that circulation gives it magnetic characteristics. Now, if the question is asked, discuss the properties of the earthquake wave, till here you will only talk about the speeds. If the question is about discuss the interior of the earth as revealed by the seismology, then you will talk only about that part which we have explained. Right? This is how speed decreases, speed increases. That means the chemical composition will be this. That means the state of matter is in a solid state, it's in liquid state. The density is increasing, density is decreasing. That is as revealed by seismology. Discuss the interior of the earth, then you will talk about the Mohr discontinuity, Conard discontinuity, and because we have much greater detail of the crustal feature as compared to the mesosphere and baryosphere, because they are much deeper. So whatever information is collected, that's a very generalized information. Right?
How are gravity and outer core?
How the?
Gravity and outer core.
Magnetic power. Magnetic power is basically associated with iron compounds. Right? नहीं, मैग्नेट किससे बनता है?
I am asking here.
तो ग्रेविटी है क्या?
Gravity is due to mass. Gravity is due to mass.
Mass?
Due to mass.
हाँ. So the presence of iron.
Plastic of it, okay? It has nothing to do with the magnetism and all. Suppose I drop it here, okay, and it attracts towards the pole, okay. Then what is the pole to do with this plastic object?
Obviously, the pulling down, the capacity, the gravity is a characteristics of Earth. Magnetism is again a characteristics of Earth. Magnetic power to attract something towards it. That is, when we talk about the magnetic in comparison, like North Pole and the similar pole repulsion and the similar poles attraction. So that is related to the same object. When we talk about other objects, Earth has its own magnetic power. That's why it's called magnetosphere. And that magnetic power is associated with that dynamo. Gravity is slightly different. Magnetism. तो different तो है ही थोड़ा, but both are associated with iron concentration in the core area, and that's why the magnetic pole is different than the geographical pole.
But we can't consider it as a bar magnet because it's a
No, it definitely not.
It's a sphere, right?
Whenever at a particular point of time, it behaves like a bar magnet.
Then how will it is north and south pole like if we consider it?
Sonia, close.
Sir, we are considering.
So Donald Trump is the new US president. हाँ? 3 वोट बाकी थे, अलास्का मिल गया उसको.
दोनों हाउस में तो
Huh? Sorry? Like he is very conservative in that sense. Obviously, immigration and all things will be very difficult. Huh?
officially won.
Hmm?
Now he is very much ready to accept the results.
Sorry?
Because he won, he said, I will accept the results only if I won the election, the
Yes. Not good. Everything is good. Why are you so pessimistic? India is not that bogey kind of country which is going to be affected by the US presidential election that much. So don't worry, we are very resilient. Not socially but economically also. If you look at the foreign institutional investors and foreign domestic direct investment, FDI and FIIs, so we have much greater proportion of FDIs compared to FIIs. So if Donald Trump does that, obviously it will have some impact over overall economy of the world. So even the worst recession of 90s, late 90s and the early 21st century has not hit India that much. So the domestic economy is much more vibrant, resilient as compared to even the Chinese. So just like Donald Trump says that it is the Chinese and Indian immigrants who are killing their jobs. He might not be understanding properly that it is they who are helping it. Just like Raj Thackeray prohibiting UP walas and Biharis. He doesn't understand that most of the economy is run by the labor class who is migrated from there. Right? Yes, go ahead. There's a good number of students are from Maharashtra also, among the online students. Obviously, I don't believe at least that those who are preparing for civil services will be having some myopic mind to think about these small issues, but he's just like Raj Thackeray of US in this particular aspect. Yeah, any question? Everything is well understood? That's cool, good. I have got some intelligent bunch of the students, lucky enough. Huh? Sorry? Shadow zone. It was first discovered by Oldham. Oldham, hence also called Oldham zone. Shadow zone is the zone of antipodal area where earthquake waves are not received. Right. S-wave shadow zone is larger as compared to the P-wave shadow zone. Since S-wave does not pass through the outer, that is liquid core, its shadow is made because of this. Right. Let's say suppose this is the earth part, here you have the focus and this is the core, this is the outer core and this is the inner core. Outer core is in solid state, inner core is in liquid state. Inner core is in solid state, outer core is in liquid state. अच्छा, I spoke differently. अच्छा, अभी माइंड में बहुत सारी चीज़ें चल रही है ना. So outer core is in a liquid state and inner core is in a solid state. Now let's say suppose here you have focus. So both S and P will move in all direction. Let's first talk about the S wave. It is going in all direction. Right? The moment it comes here, it is stopped. The moment it comes here, it is stopped. So obviously so S wave will travel in all direction, and that's why the entire zone will be a shadow zone of S wave. Right? 104 degree generally from the, if you make this as a angle. This is shadow zone. Shadow zone. I hope the term itself is very clear to all of us. Shadow zone, where the light is not available, that is shadow, and shadow is made by because of obstruction. When we are standing against the sun, so it's the back side you will have a shadow. So when the S wave is moving in different direction, the outer liquid core will not allow the S wave to pass through. Hence what will happen? The shadow zone will be created and the antipodal areas will not experience S wave.
So is there any specific region where these waves are created?
Focus.
So focus is in lithosphere or in metal?
Focus is in?
Lithosphere or metal also?
It depends upon that. Focus, we'll discuss that once we understand the plate tectonics.
So if it is near to the core, then what will be the angle?
Okay, it can't be near to the core. The deepest foci itself till now, which is recorded, whatever may be happening in and around the core, right? Then obviously it will be, it is not felt on the surface of the earth. So we don't have any recordings instruments which can really trace that. So till now we have recorded depth is 720 kilometer deep. Now as far as if you are asking that the core, this core is concerned, now earthquake outer core, right? So outer core, the displacement is not that possible because it is already in a liquid state. So even if displacement takes place, that will not generate huge amount of energy. If it happens in the inner core, then the entire vibration will remain in the inner core, right? Because outer core is in liquid state, so S wave will definitely not get out of inner core. P wave, if it gets out, may not be able to reach under the top. So that's what we are concerned generally about, is what affects the human being. All the studies are basically related with its direct or indirect impact over humans.
So this angle is 104 degrees of 720 kilometers.
From the focus, you join focus with the core of the center of the core of the earth and then join the area where you have. So this is the last point of S wave. This is the focus. You draw a line with the center and then make an angle. So that is roughly around 104 degree that will be available from 104 to 104. Right? Now that is shadow zone of S is directly related with the absence of S wave in the outer core. Since S wave cannot pass through the liquid state and the outer core is in a liquid state, it creates a shadow around the antipodal areas. Right? What about P? If you look at the P wave, once the P wave enters into the outer core, that is liquid, the speed decreases, right? The outer core behaves like a refraction prism, and because of refraction of these waves associated with the change of the medium. The shadow zone is created. Which is smaller in size as compared to S wave. Now again let's draw it. Since our childhood you must have been reading one thing, then when you put a stick into the water, the stick appears slant, slightly bent. Why? Reflection of light, right? Same thing happens here. When the P waves travels, now it enters into the, so obviously it will move in all direction, but since it enters into the liquid medium, that is rarer medium, so the moment is denser to rarer medium, they will start refracting like this. So this will be the zone, shadow zone of P. Again you can draw the diagram from any book you are consulting, whether P. Dayal or Savinder Singh, or the notes given to you, that will also be having. So there will be two separate zone of shadow zone for P waves, because some will move and will get concentrated from the core areas also, the center part of the core, which will put the opposite part a little bit of waves, but away from that the refraction is primarily associated again with the liquid core. The one which enters into it here, this also gets concentrated. Now other properties, if you look the motion of particles within the wave. Speed. Speed, medium. We have already talked about the medium also, and then motion of particles within the wave. In the P wave, the particles move to and fro or up down along the direction of the wave. It is also called longitudinal wave and is similar to sound wave. Like this. When it moves like this, up, down, up, down, up, down, in the direction of the propagation of the wave. So generally move along the radius of the earth. In the case of S wave, the motion of particles is perpendicular to the direction of the motion of particles in L wave is a combination of both P wave and S wave. That is to and fro and sideways as well. This make the most destructive of all the waves, as the shaking of the area is up down as well as sideways, creating a strong base for imbalance of the structure. It will move up down this way. Like this. Any question? सब समझ में आ गया? Right? Wavelength P highest, L P shortest, L longest. That's why it has longer amplitude also, which is also responsible for greater destruction. That's all for the day.